In my earlier video, I had talked about some of the definitions of aromaticity, that due to this continuous advancement in the organic chemistry and the techniques, the analytical techniques such as NMR, etc., the definition, the aromaticity needs to be redefined. So I had discussed some of the definitions, and why I had discussed some of the definitions earlier is because of the nature of the aromatic compounds and the nature of the compounds, mainly because of this delocalized electron sextet or the electron loop which exists in the benzenoid compounds or the compounds derived from benzene. Now, in some of the earlier videos which are on some of the popular videos also, this molecule cyclopropenyl cation cyclopropenyl cation has been termed aromatic just because it possesses the required number of the Huckel's number of electrons needed for an compound to be aromatic. Now, when I discuss the characteristics of the aromatic compounds over here, nowhere you will find that the Huckel's number of electrons is a mandatory condition. The presence of a diamagnetic ring current or the aromatic delocalized loop, equal or approximately equal bond distances, except when an heteroatom is present in the ring, because when the heteroatom is introduced, the bond distances will obviously change. The carbon-carbon bonds will transform into, some of the bonds, at least two bonds will transform into carbon, nitrogen, or carbon, oxygen, depending upon the heteroatom which is introduced. Now, planarity of the molecule, because the aromatic compounds ideally are totally planar in nature. When an heteroatom is introduced, the symmetry of the molecule is destroyed and the symmetry is distorted to some or a large extent. The more the distortion in symmetry, the lesser will be the aromaticity, or the degree of aromaticity will reduce as the distortion in symmetry rises. The another characteristic is that chemical stability. Such aromatic compounds are very stable in nature. The ease to undergo aromatic substitution reactions. These aromatic compounds very easily undergo aromatic substitution reactions rather than addition reactions. They do not prefer addition reactions. Instead, they prefer aromatic substitution reactions. Now, keeping in view these points in mind, when we look to this molecule, this cyclopropenyl cation, in a popular video on YouTube, this molecule has been termed as aromatic. Now, neither theoretically nor experimentally, this molecule can exhibit any of these characteristics, any of the 5 characteristics which have been enumerated over here, which are the essential features of an aromatic compound. Neither is this molecule planar, nor it is chemically stable, nor it is free from symmetrical distortion or strain. It is highly strained molecule, as you can see. These bond distances will vary, although these are all carbon-carbon bond distances, but these bond distances will vary as